The requirements for a product are sometimes called product specifications or specs. A spec is a value or a range of values for a physical property that is required for a product. Products are routinely tested to ensure that the specs are met. Testing can be done by direct composition measurement or by indirect composition measurement. Direct composition measurements are analyses that allow personnel to directly observe the percentages of components contained in a product. One type of instrument that is commonly used to perform direct composition measurements is a process chromatograph. A process chromatograph analyzes a product and provides a readout of the component percentages. The measurements made by the chromatograph can be compared against specs to see if any adjustments are needed to ensure that the product meets specifications. Indirect composition measurements are analyses in which one measured property is used as an indicator of another property. In other words, the measurement of a property is used to determine product composition. One common indirect measurement is boiling temperature. For example, since the boiling points of the components in a feed mixture are known, the components in a product can be indirectly identified by their boiling points. When a product is tested, its composition can be indirectly measured by recording the temperatures at which the different components in the product boil. Product specs are set by the demands of downstream processes and by the marketplace. Products must meet certain quality standards. For example, a downstream process may require a feed of predetermined quality. Sales contracts and marketing practices also require distillation systems to produce products that meet certain quality standards. Exceeding product specs or producing better quality product than is required is known as product giveaway. When product giveaway occurs, both product and energy are wasted. For example, a facility uses more utilities such as fuel than necessary, and in many cases customers may not be able to use the products. Doing this can reduce a facility's profit margin. Product composition measurements are made to make sure that the products of a distillation system are on spec. For example, the tower represented here separates a feed that contains methylcyclopentane, or MCP, and cyclohexane, or CYC6. The MCP is the lighter component of the feed, and it is removed as the overhead product. The heavier CYC6 is the bottoms product. In this example, the spec for the bottoms product is 0% MCP. In other words, all of the MCP should be removed as overhead product. The spec for the overhead product is less than 5% CYC6. To help maintain product specs, samples of the products are taken and sent to the lab on a regular basis. Indirect composition measurements are then performed to determine the percentages of MCP and CYC6 in the products. Distillation tests are run on the products to obtain their initial and final boiling points. If the initial boiling point of the bottoms product is lower than normal, it indicates that there is some MCP in the bottoms product, so the bottoms product is off-spec. If the final boiling point of the overhead product is higher than normal, it indicates that the tower is too hot. When the tower is too hot, an abnormal amount of CYC6 is sent overhead with the MCP. If there is more than 5% CYC6 in the overhead product, the product is off-spec. If the tower is too hot, the bottom temperature could be too high. If so, it should be decreased slightly. Decreasing the bottom temperature allows more of the heavier component, which is CYC6, to remain in the bottoms product. This action may decrease the amount of CYC6 passing overhead, and it should bring the products back to spec. If the percentage of CYC6 in the overhead product falls too far below 4%, there is a danger of some MCP remaining in the bottoms product. To bring the products back to spec, the bottom temperature should be increased slightly. This ensures that as much of the lighter component as possible is boiled out of the bottoms liquid. In general, changes in a tower's operation should be made in small increments. Gradual changes allow time for the process to react and minimize fluctuations that are caused by overshooting the set point. Now, product specs and the way they're controlled involve a variety of factors. One of these factors is process lag. Process lag is the time between making a change in tower operations and having the adjustment take full effect in the tower. In some larger towers, the process lag is long, and it may take up to several hours for results to develop. In smaller towers, the process lag may be shorter, and a result may be seen more quickly. Well, in this topic, we looked at product composition. Specifically, we looked at product specifications and how these specs can be tested and maintained. Now